Right, so we have the last thing in our notes are metric conversions. And there will not be a separate quiz on metric conversion, so you'll just see that on some of them on the test on Thursday. We're going to look at two different ways to do metric conversions. Metric conversions are supposed to be easier than like conversions in the English system because all you're doing is moving your decimal. You're either moving your decimal to the right or moving your decimal to the left. Compared to if we were working in the English system, so let's say that I had 3 feet and I wanted to change that to inches. So that would give me 36 inches. So in other words, not only when we use the English system, not only does our unit change, but also our number is going to change. Whereas whenever we're using the metric system, our number stays the same. We're just making it larger or smaller by moving the decimal. So that's kind of the idea behind it, why it's supposed to be easier to work with. All right, so this little chart, I don't know if it's a chart, whatever it is you want to call it, will help you if you like to just move decimals when you're making these conversions. And you will have this on the test. Once again, things like that, I think about, like if you needed it and you didn't have it memorized, you would probably just pull it up on your phone. So that's kind of the reality of things. I would do that too, because I don't have them all memorized. So in the middle here, these are called our base units. Sometimes they're called STEM, that's supposed to say base unit. But if you notice, they're all of the things that do not have any kind of prefix on it. So liter, meter, just kind of the base without a prefix. If I move over this way, then I'm on this side, all of these prefixes are less than the base. So that is down here on C. Units that are smaller than the base. So this would be the units to the right. It takes many of those to equal 1 base unit. So for instance, centimeter, we probably use that a lot, and we know that it takes 100 centimeters to equal 1 meter. So quite a few of the smaller prefixes to equal 1 of the base units. On the other side over here, we have all of our prefixes that have to do with our larger numbers. So with these, you would say that on this side, these are greater than the base. So that means it takes many base units to equal 1 of our larger prefixes. Once again, kilo is probably the one you know the most, and it takes 1,000 grams to equal 1 kilogram. Whenever you're working with these, you're moving your decimal by seeing how many places that you're having to jump. If you are going from the base to the smaller one and you're moving, you would be moving to the right. Then my number is decreasing. On this side now, if I'm moving to my left, my number should be increasing. All right, so let's work through a few, and then it seems to kind of fall into place a little bit better than a bunch of words. All right, I'm going to move this up. It's kind of hard to get it into both screens. All right, so this G is gigameters. So that's over here on your left-hand side. If you look, it's the second to the largest prefix, giga. That's what that big G stands for. So I'm going from gigameters to kilometers, kilo. So the first thing I do is I see how many places that would make, I would have to jump. 1, 2 places, right? Does everybody see that? Let's back up here. So right here, if you look at it, starting with giga, and I want to go with kilo, so that's going to be 1, 2. So that means I need to move my decimal 2 places to the right. Come back down here. So my decimal's here, 1, 2, and it would become 0.75 kilometers. Like we said, if we're moving it to the right, it's going to become larger. If we're moving it to the left, it would become smaller. Your sig figs should stay the same. In other words, I had 2 sig figs in my gigameters, and I still have 2 sig figs in my kilometers. All right, let's look at another one. Big T is tera. So that's the very last one on your left. Big M is mega. It would be little m for milli. So big M is mega. So once again, I'm going to start at tera. And how many places am I going to jump? 2 again. And I'm going 2 to the right or 2 to the left? To the right. So 1, 2. So it would become 0.091 megaliters. My number got a little bit larger. Let's see if we can find one where our number would get smaller. No, but it's still a bit larger. Let's come down here and we'll look at this one. So now we're going from mega to giga. So how many places is that? Just 1, right? My decimal's at the end of that number, even though it's not written, so I just move it over 1 place. So it would become 409.6 gigabytes. It's going to become a little bit smaller. Do y'all remember doing this in junior high? Yes, no? All right, why don't y'all give a couple a try? This one. This little funny looking U is a micro. When you're looking for the prefix, it's micro. It's on the small side. So see if you can go micro to milligrams. Hectometer to centimeter and centimeter to grams. So when I'm going hecta to centimeters, how many places am I moving? 4, right? Am I moving 4 to the right or 4 to the left? Right. So my number should be getting bigger. So my decimal is behind that 0, so I need to move it 4 places. So I would end up having 5. So I was originally here, that's where my decimal was, and I moved it 1, 2, 3, 4. So that ends up being one more. And my unit would be, change that to centimeters, thank you. Does anybody not get where we're doing the places, what we're counting on that little chart? Y'all are good on that? I'm gonna give it to you. If you're jumping places to the right, then you're moving your decimal to the right. If you're jumping places left, you're moving your decimal to the left. It follows that. Yes, ma'am. Let me get back up there so I can see. Am I counting that big square? Yes, that's a good question, because that, yes. So like if I went from kilo all the way down to centi, it would be 1, 2, 3, 4, 5. You do have to count that middle one. It's a good question. Any other questions on that? Yes, sir. Oh, you had a question? Okay. So now I'm going to show you another way to do it. It's called dimensional analysis. And we use dimensional analysis a lot during this. I love dimensional analysis, but I'm like a nerd. So this is another way to look at the conversion or the prefixes, and we're going to use this for using dimensional analysis. So dimensional analysis uses conversion factors to solve problems with numbers have different units. So it's a system where you line up a lot of conversion factors to get you from a number that has one unit to a number that has a different unit. So just, I can give you, we'll look at just a quick example of that. If I had, let's say that I had 2.2 hours and I wanted to know how many seconds that is. So those are all conversion factors that we know. So this is how you would set up a dimensional analysis. It's always done like kind of a little train track system, they kind of say. So you start with 2.2 hours. That's what you're given. And we're trying to get to seconds. So what's the first thing that I'm going to move to? Minutes, right? I would say 1 hour is equal to 60 minutes. That would be considered a conversion factor. This is a conversion factor. And then what would I need to do? Go from minutes to seconds, 60 seconds. And that is a conversion factor. And when you've done that and set up all your conversion factors, then you multiply across. So 2.2 times 60 and divide if you have anything on bottom. And that's what dimensional analysis is, that process of using conversion factors to get from one number with one unit to a different number. So when we do this, we're going to be using the exponent form for our conversion factors with our prefixes. So in other words, if I have kilo as a prefix, the number that I would be using with it is 10 to the third. All right, let me move this up a little bit and we'll just go through those steps. So remember your basic units, grams, liters, meters, those are the most common ones. So you're going to write down your information or your given. That's how you always start your problem. So when we look at our little train tracks, that given information always goes in that first box. Right now, we're not going to have anything underneath it. Remember that you need to write down the number and the unit. Because dimensional analysis is all about lining up the units so that they will cancel correctly. Then you would write down an answer blank and the desired unit on the right of the problem. So let's say that we were on that other one, we were going from hours to seconds. So my desired unit would be seconds. That's what I want to eventually get to. Then you're going to use your equivalents or your conversion factors to cancel unwanted units until you get to where you want. So if you've done it correctly, you should be left with only one unit at the end, and it should be at the top closest to your equals. And all of these are the different conversion factors. Yeah, you can have more than, probably the most that we would do was 3 conversion factors. So I call that a 4-step, but yeah. Like in AP chemistry, like we just had a quiz over it. Yeah, we had some that had like 5 or 6. All right. So you want to set up your conversion factor. This is kind of a big deal. Set up your conversion factor so that the 1 is always with the part of the conversion factor that has the prefix, and the exponent part is with the part of the conversion factor that has no prefix. So we said, for example, kilo, we said if we looked on our chart, it's 10 to the 3rd. So if I want to use it as a conversion factor, I say 10 to the 3rd grams is equal to 1 kilogram. My 1 is with the kilo, that's the prefix. And then the part that I got off the table, I was going to say memorize, but you don't have to memorize it. The part I got off the table goes with just the base unit that doesn't have a prefix. And like we talked about earlier, conversion factors can be flipped. This can also say 1 kilogram is equal to 10 to the 3rd grams. That means the same thing. Which way you're going to use them is based off of what you want to cancel out. When you got it all set up, because that's kind of all the work, multiply across. So all your numbers across and divide the bottom, and then you're going to end up with your answer. Be sure that you adjust for sig figs and include the units. Those. All right, we good? All right, so our first one, we have 100 picograms is equal to how many grams? So if you look on your sheet, your little table, right above, what is my exponent for pico? 10 to the negative 12, right? All right, so that's the one that I'm going to be using. So my given is 100 picograms. So we said that's what we're going to start with over here. And I always at the top closest to my equals with what I want to convert it to, which in this case is grams. Now this is a big part of it. You have to follow your unit. So in other words, if I'm picograms here, I have to be picograms down and diagonal because I need it to cancel out. Now we're ready to stick in a conversion factor. We said the 1 always goes with a prefix. So the 1's going to be here. And the exponent goes with just the base. Now, if you look at my units, picogram and picogram cancel out. I'm left with just grams, which is what I wanted. So now I'm just ready to put in my calculator. 100 times, because you multiply across, 100 times 10 to the negative 12. But in this case, it's 1, so it's not going to change it. And probably some of y'all can do that without even putting it in the calculator. What's that? What's it going to be? Forget. 100 times 10 to the negative 12. What do we get? Huh? Got an arrow. Everybody else, anybody else get arrow? Not an arrow, an arrow. Yes, no? Yes. That in your calculator, if it shows E, that's your exponent. Now, the reason I left some space is because I need to do the right number of sig figs. How many sig figs did I have here? That 100. How many sig figs is that? 4. So I want my answer to have 4. So I would need to do 1.000 times 10 to the 5th. And what are my units? Grams. The reason I said you may not even need a calculator on that, because this 100, to get it into where there's only one place before the decimal, I'm going to move this back 2 times, right? If I move that back 2 times, then I have to take 2 away from that negative 12. So that's one that you probably can do without a calculator. All right, let's look at our next one. Kilometer to meters, kilo. We've already done that a couple of times. What's kilo? 10 to the 3rd. All right. So same thing. I'm going to get myself going. Start with what I'm given. 0.320 kilometers, and I want to get it to meters. I follow my units. If I'm kilometers up here, I have to be kilometers down and diagonal because I need that to cancel. I need to get rid of that one. All right, so now I'm ready for my conversion factor. Where's the 1 going to go? Top or bottom? Bottom. With the kilo, the 10 to the 3rd will go up here. My kilometers canceled. I'm left with just meters, which is what I wanted. So this one, 0.320 times 10 to the 3rd. 320. Do I need to put a decimal after that 0? Yes, because this 0.320 also has 3 sig figs. And then what would my units be? Meters. Anybody have a question on that one? That process is called dimensional analysis. So let's look at the last one, kilograms to nanograms. So if you look at your conversion tables, there's not any way that I can go from kilo straight to nanograms. Probably somebody in their life does have that information, not me, but they probably can. So what is in between? What do I need to go to first? I can't just go kilo to nanograms. What comes in the middle? Grams, right? Is it grams in the middle somewhere between your kilo and your nano? That's your base unit. So I'm going to have to go kilograms to just plain grams. And once I'm there, I can go to my nanograms. So this is going to have another conversion factor, one more conversion factor. Grams is in that box in the middle. Remember, it's like a base because it doesn't have any prefix. And it's okay. So let me move this out of my way. Possibly. All right, so let's one on this one. So I'm going to start with my 750 kilograms, and I eventually want to get to nanograms down here. So start it with what I was given, and then also I want to be sure to where I want to go to. So follow my units. If I'm kilograms here, I have to be kilograms down here because that's what I need to cancel. So what's going to go with my kilograms? 1, and what's going to go opposite? 10 to the 3rd grams, right? Now, grams here, I have to have grams down here. So now where is my 1 going to go? It always goes with the prefix. So write the nano, and what is nano? 10 to the negative 9. If I look, my kilograms cancel out, my grams cancel out. I'm left with just nanograms, which is what I wanted. So why don't you try that in your calculator? As far as I know, if you have a number on the bottom that has an exponent on it, you have to put it in parentheses, but there may be another way of doing it. So we're going to have 750 times 10 to the third. And then you would get your answer for that and then come back and divide it by 10 to the negative 9, because that's what's on the bottom. Pardon me? Yeah, I would do 750 times 10 to the third. And then I personally would hit like enter or whatever to get my answer for that multiplication. And then I divide, but Cameron, the only way I know is to this, when you divide by 10 to the negative 9, it's going to have to be in parentheses. So if I'm dividing by 10 to the negative 9, should my number be getting smaller or larger? If I'm dividing by 10 to the negative 9, a little bitty number, should my answer be getting larger or smaller? Yeah, I'm dividing by a little number. Yeah, so your number should be larger than what you started off with. So who has an answer? Ten to the 14th. Just don't forget to put on your units, which in this case are nanograms. How is this bigger? Because a positive exponent, remember I'm moving my decimal this way 14 times. My number's getting really big, right? If it was a negative, I'm moving my number this way and my number's getting a lot smaller. So a negative coefficient is a small number, a positive coefficient is a big number. All right, so with that being said, probably y'all, I very seldom find anybody who loves dimensional analysis like I do. Anyway, so you can do your conversions however you want to. I'm going to give you both tables on the test. When we get down to it, there's really only a couple that we use most of the year, and we will use dimensional analysis. So if you don't want to use it here, if you like just moving your decimals, that's fine for this part of it. All right, any questions? Yes, sir, I'm sorry. No, you have a quiz tomorrow over scientific notation and temperature conversions. That's tomorrow. You will not have a separate quiz on this. You'll see it on the test on Thursday, some problem. Right. If you have, you got a few minutes to give a couple a try, or does anybody have any questions from anything they worked on this weekend? Are you going to give them? That anymore.